Hi, my name is Hazwani Izati. I am from Group 2 and I will present about two of the 8 questions from tutorial 2 of KTT 112. I will present two questions which is question 3.49 and the other one is question uh, 3.85. Okay. Let's start with the question 3.49. Where is it? Okay. Okay. I will read the question first. Okay. The compound dimethyl phthalate used in insect repellent is composed of carbon, hydrogen and oxygen and has a molar mass of 194.2 gram per mole. A 0.2572 gram sample of the compound was burned in a combustion apparatus and 0.583 gram of carbon dioxide and 0.119 gram of water were collected. What is the molecular formula for dimethyl phthalate? So now the question asks us to find the molecular formula of dimethyl phthalate. So first of all, okay, we must step 1, we must find the mass of each element or molecule. So we know we make the equation first. We write the equation first. So X which represent the unknown molecular formula of dimethyl phthalate. So dimethyl phthalate react with oxygen to produce carbon dioxide and water. So we know that the mass of sample given is 0.2572 gram. So we must find the mass of each element or molecule. So firstly we must find the mass of carbon. Okay, we know that the mass of carbon dioxide is given, right? So the mass of carbon dioxide we times with the molar mass of carbon. Molar mass of carbon per molar mass of carbon dioxide. So we okay. So from this we can find the mass of carbon only because we can cut this and cut the carbon dioxide. So we only get the mass of carbon. So mass of carbon is 0.159 gram of carbon. Okay, next we must find the mass of hydrogen. So how we can find the mass of hydrogen? We can find the mass of hydrogen from the mass of water given from the question. So like we do previously how to find the mass of carbon, so that we use the same way to find the mass of hydrogen. First we times the mass of water given with the molar mass of hydrogen per over molar mass of water. So okay, molar mass of hydrogen is 1.0, right? So there are two molecules of hydrogen, so 2 times 1. So we times with 2 over 18 gram of water. So then we get the mass of hydrogen. So mass of hydrogen, I get 0.0132 gram of hydrogen. Okay, lastly, we must find the mass of oxygen. So how to find the mass of oxygen? We just take the mass of sample, then we minus with the mass of carbon and mass of hydrogen that we have found before. So okay, we times with the total mass of carbon and hydrogen, then we get the mass of oxygen, which is 0.0852 gram of oxygen. Okay, next. Okay, Step 2, we must find the empirical formula. Okay, how to find the empirical formula? We just do like this, make the table like this. So first row is element, second row is mass of each element, then number of mole, ratio, and finally simplest ratio. So from the calculation before, we just got the mass of each element, right? Okay, we know we get the mass of carbon 0.159 gram, hydrogen 0.0132 gram, and oxygen 0.0852 gram. So from the mass that we have got, we can find the number of mole of each element. So how to find the number of mole? We must okay, the formula for number of mole is mass of element over molar mass of the element. Okay, so the mass of carbon 0.159 gram, we divide with the molar mass of carbon, which is 12.0 gram per mole. Okay, so finally we get 0.01325 mole, and so on for hydrogen and oxygen. Just same with the calculation is just same with this. Okay, next we must find the ratio. So how to find the ratio? First we must find which element has the smallest number of mole. So from this we can find that the number of mole of oxygen is the smallest, which is 0.005325 mole. So how to find the ratio? We take this value, divide with the smallest number of mole, which is 0.05325 mole. So we get the ratio for oxygen is 1. And okay, for carbon, the number of mole for carbon is 0.01325 mole, right? So we divide with the 0.005325 mole. So we get 2.5. And hydrogen also same. We also get 2.5. So simplest, next we must find the simplest ratio. We don't want this decimal because ratio we don't need the decimal. So how to how to um, how to make this number to become a whole number? So 2.5 we can times with 2, so we will get 5. Okay, no more decimal. Okay, so we must times the all the ratio with 2. 2.5 times 2, 5. Also this 2.5 times 2, 5. And this 1 times 2, 2. So finally, therefore we get the empirical formula is C5H5O2. Okay, step 3 we must find N. Okay, N. Before we find the molecular formula, we must find the value of N first, so that then we can find the molecular formula of dimethyl phthalate. So okay, it's given that the molar mass of dimethyl phthalate is 194.2 gram per mole. You can find this value from the question. Okay, so how to find the value of N? Okay, just do like this. C5N times plus H5N plus O2N. Okay, equate with 194.2. Okay, okay, then finally we get N equal to 2. So last step is step 4. Now we can find the molecular formula of dimethyl phthalate. So the molecular formula, we already get the value of N, which is 2. So C5H5O2 times with N, which is 2. Then lastly we get the molecular formula of dimethyl phthalate is C10H10O4. That's how we can do it. Just easy. Okay, next I will present question 3.85. Okay, this question. Okay, I will read first. Calculate the maximum numbers of moles and grams of iodic acid HiO3 that can form when 625 grams of iodine trichloride react with 118.5 grams of water. So, okay, you can see the equation which is unbalanced. So, how many grams of the excess reactor remain? Okay, firstly, we must balance the equation. So, after balance the equation, we will get 2ICl3 plus 3H2O produce ICl plus HiO3 plus 5HCl. Okay, second step, we must find the limiting reactant. Okay, find the limiting reactant. How to find the limiting reactant? We must find the number of mole of each reactant from the equation. We know that the reactant is ICl3 and H2O. So we find the number of mole for both reactant. Okay, for ICl3, we get 2.72 mole, while for H2O, we get 6.58 mole. Okay, we already know that how to find the number of mole, which is we can take the mass of take the mass given, then we divide with the molar mass of the molecule. Okay, so we can compare the number of mole of both reactant, okay, which is smaller. Okay, we get that the number of mole for ICl3 is smaller than the number of mole of H2O. So automatically the ICl3 will become the limiting reactant, while H2O become the excess reactant. Okay, next, okay, we find. Okay, the question asks us to find the maximum numbers of moles and grams of iodic acid. So we answer the first question. Okay, in this step 3. So maximum means that we have to take the limiting reactant. Take the limiting reactant and we times with we do stoichiometry. We must we must find the number of moles and gram of HiO3, right? So we take the HiO3 stoichiometry. So we know that sorry. Okay. 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 The number of mole of ICl3 we times with 1 mole of HiO3 over 2 mole of ICl3. So then we can get the number of mole of HiO3, which is 1.36 mole HiO3. Then how to find the mass of HiO3? We just take the number of mole HiO3 and times with the molar mass of HiO3. Then finally we get 239.23 grams. Okay, next is last step for question 3.85. Step 4, find the mass of excess reactant remain. Excess reactant remain. Okay. So, okay, we take the number of mole of limiting reactant, which is ICl3. So now we have to find the mass of excess reactant remain. Excess reactant is, we know that the excess reactant is H2O, right? So we do stoichiometry with H2O. Okay, from the balance equation, we know there are 3 mole of H2O, then divide with 2 mole of ICl3. So then we get the number of mole of H2O, which is 4.08 mole of H2O. Then from the number of mole of H2O, we can find the mass of H2O used. Okay, used. Then okay, how to find the number of mole of H2O? We times with the molar mass of H2O. Okay, then we get 73.5 gram of H2O. Okay, the question asks us to find the excess reactor remain. This mass is mass for H2O use. Okay, so how to find mass of H2O remain? Okay, from the question is given that the mass of H2O is 118.5 gram. So we minus with the mass of H2O used, which is 73.5 gram. Then finally we get 45.0 gram. Okay, that's all from me. Thank you.